whole thing is about trying to figure out how differentiability and continuity tie into each other. Oh, I don't even know why I'm looking at this. Kylie, do you remember what differentiability means? Because honestly, calc, the hardest part for some students is there's so many different terms and words that if you don't even know what it's saying, then it's like, you know, you have no idea what's going on if you don't even know what the words are. Do you remember what differentiability is?
Not really, no.
Okay, how about continuity? That one you probably do.
Yeah,
Continuous, right. Differentiability means something is differentiable, which is kind of another word for derivative. So differentiability means, are you able to take the derivative at that spot? So if something is differentiable at like x equals 3, that just means you're able to find the slope at 3. And it definitely bothers me that there's so many different terms that kind of mean the same things. And I get why they have different terms because they're kind of used in different situations, I guess. But to me, it would make calc a lot more accessible and easier learned if it was more streamlined. And I get why it's not. It's just, okay, so that's what we're trying to look at. When it says differentiability at a point, we're trying to figure out, are you able to find the slope at a spot? That's what this is saying. Actually, I'm going to change my mind. Let's roll. Kylie, do you want to roll?
Yes, that'd be great.
Okay. You can't get called on when you roll. I picked on you, so I feel that's fair. We don't. And we're going to have a lot of missing people today, so.
28.
Cool. You look super happy. You didn't want to get called on?
Huh?
Do you want me to skip you?
No.
Okay. I'm not sure the best way to phrase this question. What does this say? Well, what happened there? Where's my marker? Like, clearly this is the whole point of this box. I don't know if you can distinguish that or, you know. Let's start with the left-hand side.
What?
It says the limit as x approaches c minus. And then, do you remember what that formula is?
No, I haven't really used something like that.
Okay. Does anybody else recognize that formula, what it's from? It's the alternate way to find slope. So it's alternate form of a derivative. We don't use it much. It was basically part of that one section that we did a lot of. So when you're looking at this formula, maybe I'll try different colors. This is the slope on the left. This is a big part of calc, trying to distinguish and like read what you're given. This is why a lot of high school students that take calc here and then retake calc 1 in college are usually very successful doing that because you're used to a lot of the notation. It's not such a big shock seeing everything, that it helps quite a bit. This one, since it is C plus, would mean find the slope on the right. All right, Cole. Now that we've interpreted this, does that help you figure out what that says, or do you want me to pass it on to somebody else? Because I could do that too.
A function is differentiable at x equals c if the slope on the left equals
Sure, that works, perfect. The L being a finite value just means it has to be a normal number. So like, the answer can't be infinity. That's why that L being a finite value is there. But very good. It's basically saying if your slope on the left and the slope on the right are the same, then it's differentiable. Which kind of makes sense. Like, if they're the same, then that's the slope. But there are lots of places that doesn't happen. This is probably the most famous one. Do you guys think you could answer A and B right away? Or should we do them together? Because we can.
Together.
Together? All right, sounds good. Let's go, Kylie. Who do we have?
13.
13. Look at you pre-rolling. Caden. Do you want me to try to interpret as we go to help find the answer? Okay. It says, what is f prime of x? Do you remember what the prime meant?
No, not really.
Slope.
Okay.
If you see f prime of x, that means slope.
Okay.
So what is the slope on the left-hand side of 1?
Like -1.
Perfect. Perfect, that's exactly what it's asking. Do you think you could probably answer B then pretty quickly since you know that one?
1.
Perfect. So it has a different slope on the left and the right because it comes to a sharp point. Is f continuous at x equals 1? Let's go with somebody else unless you wanted to just run the table on A through D.
Let's go with somebody else.
Okay.
11.
What'd you say, 11?
11.
My ears are still plugged. Abby,
Hi.
do you remember what continuous meant again? Like you could draw it without picking up your pencil? Okay, so at 1, can we draw this V without picking up our pencil?
Yes.
Yeah, so it's continuous. Okay? Is f differentiable at x equals 1? Do you want to answer that one, Abby?
No.
No? Okay. We can go to somebody else.
12.
12? Oh, no. What? We've gotten all numbers right together here. Do you feel like you know this one?
Yes. No.
Oh, okay. So you were saying yes, you know this one.
No.
Okay. How come you think no?
Because the slope is different from both sides.
Good. The slope on the left and the slope on the right are different. Differentiable means that they would be the same. Now, all this is basically saying, which we have actually answered this before, if I asked you to find the slope at the tip of a V, you can't because it comes to a sharp point. It doesn't make a curve. Okay, fair enough. No. Okay, we can talk about this, but we don't need to go through the work to show that because that just takes up a lot of time. All this is asking is what is the slope there? And it's basically saying the verifier to show it. But the slope here would be straight up and down. So if you were to do a slope formula, what would the number look like to get an undefined slope?
No. So I wanted to say infinity.
You would get some number over 0. If you get something over 0, that would be an undefined slope. So straight up and down. If it was 0 over a number, this is 0, which is a flat line. These are the two most confusing ones for most because they're super easy, but you have to try to think in your head to keep them straight. I don't know if we need to do 3, but like 3, the whole purpose of 3 is, remember in the definition it said that the slope on the left and the slope on the right have to be the same, but it has to be a finite number. So the slopes of this one would be infinities. One would be positive, one would be negative, but nonetheless, they're infinities. So even if they are the same, it's not differentiable. Okay, so this box is important. Differentiability implies continuity. What it is saying is next to number 1. If you know that a function is differentiable at a number, automatically it will be continuous at the same number. But the opposite is not true. I wanted to say converse, but it's been so long since I did geometry, I don't remember if that's the right word. Is that the right word? Converse, like the opposite?
Conversely.
Yeah, I mean, that's where the word conversely, I think, comes from. So, if something is continuous at a number, it does not mean that you'll be able to find a slope. So it only goes one direction. If you are able to find a slope, it guarantees that it's continuous. It doesn't mean the opposite way. Now this seems kind of like you're probably wondering why I'm making a big deal out of this. Here's an AP question that you'll get. That would be very similar to a question you get. And you'd have to be able to kind of figure that out. Sure, let's roll. Yeah, why not? Everybody looks way too scared to answer.
15.
Sophie, thoughts? Yeah, that's true. You do have a 50-50 chance at this no matter what. Even if it's an educated guess, sound confident, and then that way if you guess right, everybody thinks you knew it.
I'm gonna say no, because continuity doesn't necessarily mean that it's differentiable.
You're perfectly backwards, actually.
Oh, really?
Yeah. So you were answering the opposite question. You were answering, is it differentiable?
Okay.
But the question was, is it continuous?
So it'd be yes, because differentiable.
Yeah,
implies
yep.
continuity.
So on this one, how do we know it's differentiable?
Because we're given differentiability.
We were told the slope. We were told the slope at x equals 2 is 6. So it doesn't directly say it, but if you have a slope answer, then that means it's differentiable, because differentiable means you can get a slope answer. So it won't directly say things, but you're just supposed to kind of make connections. And I'm okay if you don't get these connections yet, like this is what we're working on. So this one tells you it's differentiable, and then it says, is it continuous? Yes, because that's literally what this says. No, I mean, you did good, because you even had logic in there and everything, so that's good. But that is definitely a teacher tip of mine. If you're not sure of the answer, but you sound confident, everybody believes you. I guarantee you've had teachers that have told you completely wrong things. But when they sound confident, you believe them. Not that I would do that. Other teachers. Let's see if you guys can answer 4. Caden. Long night? Okay. We better roll number 27 next. We have to wake Caden up. Just make some shaky noises and say 27. See, when you roll, you pretty much have the power. Nobody can read it except for you. So you can yell whatever number you want.
I already saw it, it's not 27.
It definitely was 27.
26
Well, that would be awesome. What was it?
Number?
Sure. Irene? You got called on yesterday, too. I'm going to blame the roller. Don't blame me. Thoughts on this one, or do you want to pass since you get called on so much? Okay, I feel that's fair. Yeah, Jimmy. I would like to try to say nothing on this to see if you guys can kind of like figure this out. How about this? Are you getting stuck on the word differentiable, like what it's asking?
Yes.
No? That's part of it. This question is asking you, where would you be able to find slope answers? So a lot of times, like remember when we did continuous? We looked to see where it wasn't continuous. So if you're asking where is it differentiable, it'd be easiest to look where you can't find the slope. You can find the slope out at infinity. I mean, like, kind of. I can certainly pass if you want. I wanted to try not to help on this one so much. How about a guess? Looking at that picture, where are weird spots that you wouldn't be able to find slope? Because that's where you can't find slope, weird things. Yeah, that's exactly right. At the little V spots, at the sharp points. You can't find the slope here and here. It's not differentiable at those spots because the slope on the left of the tip is different than the slope on the right of the tip. We don't even know the slope, but we don't care. We just know they're different. So there's different ways you can answer this. We could say it's not. I can't read those numbers. Oh, why are they at weird spots? It's at square root of 5. I mean, I'm not expecting you to know square root of 5. I was going to guess you guys would probably put like 2-ish, like 2.2 or something. That'd be fine. So we could answer that it's not at those spots. We could also answer that it's differentiable from negative infinity up to negative square root of 5. It definitely is a lot of work. Negative square root of 5 to square root of 5. You know what? I didn't even leave space for the u's in between. Sloppy. The rookie mistakes. I'm okay with you answering either way. Now, this top way is obviously shorter and quicker, but this top way just is confusing for some people. Like, it just doesn't click or make as much sense. So I know there'll be a lot of people answering this bottom way because it makes more sense. Questions so far? I mean, ask away. Because my impression that I'm getting right now is you guys are feeling confused on these questions, but yet nobody's asking anything. And I get it that, maybe once you hear an explanation, it makes total sense. But then if that was the case, when you see different questions, you should be able to take the total sense and apply it. Yeah.
So, is that how you justify your answer, or?
No, you're right. I skipped over that instructions. I honestly did not even see it, and that's pretty terrible of me. The justification I said out loud, but I didn't write down. The slope on the left and the slope on the right at both plus and minus square root of 5 are different. So that would be the justification. I feel like you guys can do this one if I give you the derivatives. I'll do that. I'll give you the derivatives. And then I'm hoping you guys can tell me where it's differentiable. Because this question would actually take you a really long time if you had to find all derivatives separately. That's a -2. So these are the derivatives of the three equations on the left. Where is this function differentiable? Which you could do the alternate half and figure out where it's not differentiable. Is this something you guys could feel you figured out right away on your own? Or is this something you feel like we need to kind of start together? Okay. All right, let's roll somebody.
14.
I think we've covered everything from 10 to, oh, Maddie's gone. Panam. What are we trying to figure out? Do you remember what differentiable meant? Okay, so the slopes are the same on the left and the right of a spot. So each one of these three equations on their own are like normal polynomial things. So each one of these on their own would be differentiable everywhere. Where is it possible that they may not be differentiable? Like there's two spots where it's possible they might not have the same slopes on the left and the right. Yeah, Panam's voice got really deep quickly. Check 0 and 3 to see if the slopes are the same on the left and the right. Because those are the only spots, the breaks in the piece function. So piece function has breaks at those spots. We're going to check those spots to see if they have the same slopes. And we'll just start with that, even though there's actually more to it. Let's roll somebody outside of the teens.
6.
All right, you did.
I just answered.
Yeah, you did. You did. You're right. Well, no. He's going to answer again. Yeah. He wasn't supposed to answer last time. He just wanted to. Unless Panam wants to go again. Oh, okay.
2 and -2.
I literally have no idea what you're telling me.
I asked Kid for an answer, and that's what he said.
You can't just give me random numbers. Just because it's math doesn't mean like numbers are an answer.
You're supposed to plug into 0 and the 3 into that x plus 1 and the 4 minus x whole squared.
So if I plug 0 in there, we get
I mean those.
2.
Yeah.
If I plug 0 in here, we get 2. If I plug 3 in here, I get 2. If I plug 3 in here, I don't know what I get. -2 times 4 minus 1. -2? Okay, so these have the same slopes. These don't. Automatically, where is it not differentiable? Horrible word to write, I know. Not differentiable automatically at
3.
x equals 3.
Yeah.
Okay,
X equals 3.
now, these two having the same slopes, here's the other annoying fact. This doesn't mean it's differentiable. Do you remember in piece functions when we draw them, sometimes the pieces don't match up? They might even have the same slope, but it doesn't mean they match up. So we're going to have to check that they meet up and they have the same slope. So we started with the slopes right away and basically eliminated 3. So we don't even have to check 3 anymore. But we are going to have to check at x equals 0 if they have the same height. So at x equals 0, it has a height of 1. At x equals 0, it has a height of 1. So we did find out that they meet up and they have the same slope. So it would be differentiable at x equals 0. I should say differentiable at x equals 0 and everywhere else. except for 3. So we could answer this a bunch of different ways, but I thought it might be helpful for me just to write this information just for you guys to learn.
I'm a little like, where did you get that green stuff from?
Oh, you don't know how to do that yet.
Oh.
I got the green stuff because that would be the equation I would get if I did the derivative formula. The limit as h approaches 0 of f of x plus h minus f of x over h. If I did that for each of those 3 equations, that's what I'd get as the answer. You'll learn how to find that answer pretty quickly as we go. It's quite annoying that you can find derivatives in your head after doing it with limits. But yes, those are the derivatives. Should I move on, or is this like, because ask away if there's parts of this that are confusing, because you're gonna have to do it on your own. That's why I'm okay with questions. Yeah.
Would we be giving them like that green?
Oh, it's a good question. By the time we get there, you won't need to be given it. I don't know if there'll be a question like this, and I didn't even look at the homework, because it's possible there's a question like this in the homework. If there is, I can give them to you. Otherwise, these questions take forever. I mean, like, that's the problem with that. I think this was just kind of different, but this is one we already did, so I didn't feel like we needed to do this one. This was part of chapter 1. Like, you had to find where it's continuous. So you'd plug in x equals 3, and then set them equal to each other to figure out a. Here, I was going to say, I thought I remembered a part with the calculator. Here we go. Now this is the part you're probably going to like, but be annoyed to find out your calculator can do all this. So let me open up my calculator. I can't see it on the screen because it's gray. There it is. First of all, does anybody have a TI 83? Oh, nice. Oh, no, there's a TI 83 right there. So you're going to have to type it in a little different. Yep, you'll still be able to get the answer, but it'll be typed in different. And I can't remember which hour had the Inspire people. I don't think it was this hour. Was it? Okay, Inspire people, it's a different spot as well. Any Casios? This is the worst part about calculators. They're all in different, you have one? No, oh, okay. The buttons are all in different locations. Okay, so if you have a TA84, there's actually 2 places to find this. One is the secret menu, which you have to hit alpha, and then F1, F2, F3, F4, which I think it's an F2. Yes, it is. The third one, derivative. Okay, I'll hit clear. The other spot you can find it is by hitting the math button. So this is where you'd have to go on the 83. So if you hit the math button, there'll be n derive. I think you might have to scroll down to see number 8.
Yeah, I got it.
Okay, you found it. All right. But either way, on the 84s, it's the same spot too. So like some people just don't like going to that secret hidden menu. So derivative. I know it comes. I forget what it looks like in the calculator. Just say n derive parentheses.
Yeah.
Okay. So we're going to have to put an x here. You're going to type the equation first,
I think so.
I believe. Is it in the notes? No, it might be on the next page. Either way. Okay, so you have to put an x here for T84s. This blinking spot is where we type any equation. We can do the one from the notes if you'd like, which was x squared minus 5x plus 6. So x squared minus 5x plus 6. All right. And then over here is what x value we want it to be at. So let's just say x equals 2. And this will tell us the slope at x equals 2. So if you ever want to check any of your work, you can. This also could be used for you to find, like that piece function one we just did. You could type in the piece function equation to find the slope at a spot. So on the 83, I think you type the equation, comma, x. Do you know what a comma is? Okay. So comma, x, comma, and then the number you wanted, I believe. So what did we say, 2? And then parentheses. Did that work? I can't remember if that's the right order.
Might not be doing it right.
Okay, well, we'll figure it out together too. But yeah, it's somewhat the same. It's just. Do you guys want me to go through that again with you? Oh my gosh, what happened in here? It's Tuesday. Wake up.
So that's the slope at x equals 2.
That is the slope at x equals 2. d dx is notation for derivative. I think we showed this at the beginning of chapter 2, but we haven't actually used it yet. d dx is notation for derivative. It's like, this is like the notation you use when it's a verb. Like, I am taking the derivative of this equation at this number. So here's what your calculator cannot do. Your calculator can't do the derivative on its own. It can only find the derivative at a number. If you have a TI Inspire, then it can find the derivative for you. So the CAS that's at the top of those calculators, that is the reason why they're not allowed on the ACT or the MCA, but that doesn't matter. The AP test, though, it is allowed. And that's because they designed the AP test where it wouldn't be an advantage. But on the ACT, the reason it's not allowed is because it can actually do the algebra for you. CAS is computerized algebraic system. So it can do algebra. Okay, well, I guess if you don't want to see any more, that's fine. That's all there is. So that's how you can find slope at a spot. And then on the next page was for you to practice trying this. So A, you already know that you shouldn't have an answer because that's the absolute value and that's the tip of the V. And there shouldn't be a slope. And I don't know if your calculator is just going to tell you error or if it's going to tell you something else. So this is the problem with using your calculator sometimes, is that it may not give you an accurate answer. So these are the examples we did at the beginning of the section. But try, do you know how to type in absolute value?
If you go math, number, and 1, that's absolute.
Yes. So hit math. What? Math. Move over. The very first one that says ABS is how you type in an absolute value. That's not going well. I don't know the answer to this one. Negative 2. Okay, now your calculator may not tell you any of this information, but this is information we could figure out without the calculator. What did it tell you for the first one? Did it give you 0 or error?
0.
That's what I thought. So what your calculator does is it averages the slope on the left and the slope on the right. So it basically plugs in super close numbers to 1 before and after, and then it averages them. So the positive and negative being identical, but opposite, so it averages them to 0. This one, it may just give you a big number. What did it give you? 100. That's not even as big as I expected, actually. And C is a vertical asymptote, so it probably just is going to say error.
It gave 0 for that one too.
Really? These must be picked, specially picked so that you get answers. Because usually vertical asymptotes, your calculator just has a lot of troubles with, and so it often says error. Okay, but anyway, so this is kind of here to show you, don't fully depend on the calculator. Because your calculator has, I want to say limits, and that's going to sound like terrible math wording. Your calculator has limited capabilities. And all 3 of these are incorrect and wrong. Yeah.
How do you know the first one's a sharp point?
Absolute value. If I go back 3 pages,
So it's always an absolute value.
no. But this is the first one. This was the second one. These were the examples we did together. Oh, you know what? This was the example we skipped. That's why I don't remember it. So that's the only reason they were there, is because we did them together. All absolute values, they generally will have sharp points if it has to flip some negative. Nope, we're good with that. And I think this is it in the notes, right? Yeah. I thought this thing would go fast. We even took our time a lot.